Human Immunity by Alina Tipton. What is an infection? An infection refers to the invasion of foreign invaders, such as bacteria or germs that can lead to disease or illness. Infections can start anywhere in the body and can cause mild to severe symptoms and cause different responses from the immune system. Ways to catch an infection include direct, indirect, insect bites, and contaminated food. Defense against disease. The first and second lines of defense refer to the body's immune system mechanisms that protect against pathogens and foreign invaders. First line of defense. First line of defense consists of physical and chemical barriers that prevent pathogens and foreign invaders. Skin prevents pathogens from entering the skin due to its outer layer, the epidermis, which is composed of tightly packed cells that provide a physical protective barrier against pathogens. Stomach acid. Hydrochloric acid is secreted by the stomach and creates an unfavourable environment that kills bacteria and pathogens that enter the body through food. Cilia protect the body by trapping pathogens and bacteria in the respiratory tract. Using its hair-like structure, it sweeps the foreign invaders away to prevent further infection. Second line of defense. The second line of defense involves non-specific immune responses that target and eliminate pathogens that breach the first line of defense. Fever is a physiological response of the body that occurs to illness, injury, or infection. Elevated body temperature accelerates the immune response, enhances the activity of immune cells, and promotes the production of cytokines, which regulate immune function. Inflammation. When tissues are damaged or infected, the body initiates an inflammatory response. This involves the release of chemical mediators such as histamine, which dilate blood vessels and increase blood flow to the affected area. Inflammation helps to contain pathogens, remove debris, and promote tissue repair. Third line of defense. The third line of defense, also known as acquired or adaptive immunity, is a sophisticated and highly specific system that provides long-term protection against specific pathogens. Unlike the first and second line of defense, which provides immediate, non-specific protection, acquired immunity develops over time in response to exposure to pathogens and other foreign substances. This process involves specialised immune cells and molecules that work together to recognise, target, and eliminate specific pathogens, providing a tailored and targeted defence mechanism. Sensitivity to antigens. Recognition of antigens. Acquired immunity is sensitised to antigens, which are molecules or structures on the surface of pathogens that trigger an immune response. Antigens can be proteins, carbohydrates, lipids, or other molecules that are recognised as foreign by the immune system. Memory and specificity. One of the key features of acquired immunity is its memory. After an initial encounter with specific antigen, B cells and T cells develop into cells that remember the antigen. The roles of different types of immune cells. The immune system is composed of various types of immune cells, each with specific roles and functions in defending the body against pathogens such as bacteria, viruses, fungi, and parasites. Lymphocytes. If foreign invaders try to attack the immune system, again, lymphocytes remember and recognise these. Lymphocytes begin their life in bone marrow. Some stay in the marrow and develop into B lymphocytes. Others travel to the thymus and become T lymphocytes. These two cell types have different roles. Antibodies are produced by B cells, and when they remember or recognise an invader, they will alert T cells, which is then responsible for communicating with other lymphocytes and killing compromised cells. A further lymphocyte, known as a natural killer cell, can recognise a virus within a cell and destroy them. Phagocytes are a type of white blood cell that has an important role in helping maintain the body's defense against disease. Phagocytes break down pathogens by absorbing them. Neutrophils rapidly respond by containing and eliminating pathogens. Macrophages have multiple functions, including producing cytokines and clearing pathogens. Dendritic cells are responsible for coordinating reactions to protect and defend the body. Monocytes help with tissue repair and act as an immune surveillance. Mast cells help to contribute towards pathological and protective processes in the body. To summarise, the third line of defence, or acquired immunity, is characterised by a specificity and sensitivity to antigens. Though the recognition of antigens by B cells and T cells, the immune system mounts a targeted response that can effectively eliminate pathogens and provide long-lasting protection against future infections. Roles of different types of immune cells and immunoglobulins. These immune cells and immunoglobulins work together to mount effective immune responses against pathogens, protect against infections, and maintain immune homeostasis. Self-recognition and tolerance. Self-recognition and tolerance are essential concepts in immunology that refer to the function of the immune system and maintaining a self-tolerance, which is the body's defense of recognizing its cells and targeting foreign invaders. Self-recognition relies on molecular markers known as self-antigens, which are unique to the body's cells and tissues. These self-antigens are recognized as self by the immune system, helping to distinguish between self and non-self. Self-recognition is the immune system's ability to identify and differentiate between the body's cells and tissues and foreign or non-self substances. This process is crucial for maintaining immune homeostasis and preventing harmful immune responses against the body's tissues. Tolerance refers to the immune system's ability to tolerate and not mount an immune response against the body's cells and tissues. This tolerance is essential for preventing autoimmune diseases where the immune system mistakenly attacks and damages healthy tissues. Tolerance mechanisms operate at multiple levels to maintain immune tolerance. You have central tolerance, peripheral tolerance, and immunological privilege. Rejection of transplanted organs. Organ transplantation involves the transfer of organs or tissues from one individual to another. Rejection occurs when the recipient's immune system recognizes the transplanted organs as foreign and mounts an immune response against it. The main mechanism of rejection is the recognition of foreign antigens on the transplanted organ by the recipient's immune system. These antigens may include mismatch MHC molecules or other donor-specific antigens. There are two main types of rejection: hyperacute rejection, which occurs immediately, and acute and chronic rejection, which happen days to months after transplant. In summary, self-recognition and tolerance are essential for maintaining immune homeostasis and preventing autoimmune diseases, while rejection of transplanted organs occur when the recipient's immune system mounts an immune response against foreign antigens present in the donor organ. Understanding these processes is crucial for improving the success rates of organ transplantation and developing strategies to modulate immune responses for therapeutic purposes. Immune system disorder. Rheumatoid arthritis is a chronic autoimmune disease that primarily affects the joints, causing inflammation, pain, and damage to the synovial membrane. The main symptoms of rheumatoid arthritis are joint pain, swelling, and stiffness. It may also cause more general symptoms and inflammation in other parts of the body. Systemic lupus is an autoimmune disease that can affect multiple organs and tissues in the body, including the skin, joints, kidneys, heart, lungs and brain. The main symptoms include joint and muscle pain, extreme tiredness that will not go away no matter how much you rest, rashes that usually come on after being in the sun. The rash is often over the nose and cheeks. Acquired immunity. Natural active immunity occurs when an individual's immune system responds to exposure to a pathogen during the course of an infection or illness. The immune system produces specific immune cells and antibodies that target and eliminate the pathogen, leading to development of immunity against that particular pathogen. Artificial active immunity occurs when an individual's immune system is stimulated to produce an immune response by vaccination or immunization. Vaccines contain weakened or inactivated forms of pathogens or specific antigens that stimulate the immune system without causing disease. The immune system mounts a response, producing memory cells and antibodies that provide immunity against future exposure to the pathogen. Natural passive immunity. This refers to the transfer of antibodies from one person to another, typically from a mother and her child. This transfer occurs naturally either through pregnancy or breastfeeding. The transfer of antibodies can provide temporary protection to the infant against specific pathogens until the immune system matures. Artificial passive immunity occurs when performed antibodies are administered to an individual to provide immediate protection against a specific pathogen. This can be achieved by administering antibodies obtained from a serum or immune individuals, or through administration of monoclonal antibodies. Immunological memory. Immunological memory is a key feature of the adaptive immune response, allowing the immune system to remember and respond rapidly to previously encountered pathogens or antigens. Memory B cells and memory T cells play critical roles in providing long-term protection against infections and are essential for the success of vaccination strategies. Immune response to vaccination. The immune response to vaccination involves the activation of the immune system to produce a protective response against specific pathogens or antigens contained in the vaccine. Vaccines are designed to mimic natural infections without causing illness, thereby stimulating the immune system to recognize and remember the pathogen, providing immunity against future exposures. In summary, vaccination stimulates the immune system to produce a protective response against specific pathogens or antigens by activating both innate and adaptive immune responses. The generation of immunological memory ensures long-term protection against future exposures and is a key feature of successful vaccination strategies. Herd immunity and vaccine programs. Herd immunity or community immunity is a concept that refers to the immunity of a large proportion of the population against infectious diseases. This immunity can be from either a vaccination or a previous infection. Herd immunity can protect the population by slowing the spread of disease and infection and decreasing the risk of outbreaks. This is an important concept that can help protect vulnerable individuals who are susceptible and or cannot be vaccinated for reasons such as medical. Vaccination programs are public health initiatives aimed at vaccinating individuals to prevent spread of infectious diseases and protect public health. These programs involve the systematic administration of vaccines to target populations, typically based on age, risk factors, and disease prevalence. Vaccination programs may include routine childhood immunisation schedules, which recommend specific vaccine at certain ages to protect against common childhood diseases. Other vaccination programs target specific populations, such as healthcare workers, travellers, or individuals at high risk of certain infections. Vaccination programs often involve collaboration between government, health agencies, healthcare providers, vaccine manufacturers, and community organisations to ensure vaccine availability, accessibility, and uptake. Factors affecting vaccine uptake. Vaccine hesitancy. This is where there is vaccine availability, however, an individual chooses to refuse or is reluctant to be vaccinated. There are many factors that can affect an individual's decision making, such as misinformation, genuine concerns regarding the vaccine, or myths about it. Lack of trust in healthcare providers or government authorities, and religious or physiological beliefs. Access barriers such as limited availability of vaccines, transportation challenges, cost of vaccines, and lack of healthcare infrastructure can hinder vaccine uptake, particularly in underserved or marginalised populations. Socio-economic factors refers to the influences that can affect vaccine uptake, which can include level of education, income, health. Individuals with higher socio-economic status may have better access to healthcare services and resources, leading to higher vaccination rates. Cultural and religious beliefs can impact vaccine acceptance and uptake. Some communities may have cultural or religious objections to vaccine or specific vaccine ingredients, leading to lower vaccination rates. Vaccine confidence refers to individuals' trust and confidence in the safety, effectiveness, and importance of vaccines. Building vaccine confidence through education, communication, transparency, and community engagement is essential for promoting vaccine uptake and reducing vaccine hesitancy. In summary, herd immunity, vaccination programs, and factors affecting the vaccine uptake are interconnected concepts that play critical roles in preventing infectious diseases and protecting public health. Achieving high vaccination coverage, addressing barriers to vaccine access, and building vaccine confidence are essential for ensuring the success of vaccine efforts and maintaining herd immunity in communities. Benefits of vaccination. Vaccination offers a multitude of benefits, both at an individual and population level. Prevention of disease, protection of vulnerable populations, eradication and control of diseases, reduction of healthcare burden, cost effectiveness, herd immunity, global health security, and improved quality of life. In summary, vaccination offers a wide range of benefits, including disease prevention, protection of vulnerable populations, eradication and control of diseases, reduction of healthcare burden, cost effectiveness, herd immunity, global health security, and improved quality of life. Investing in vaccination programs and promoting vaccine uptake is essential for providing these benefits and ensuring the health and well-being of populations worldwide. Thank you for listening.